Hello everyone, welcome back to the stream. Today we're gonna continue with the Vulkan tutorial. Last time we started to create the uniform buffers, descriptor layouts and so on. But if you take a look at our program so far and we run it, we get this validation error that for each set n that is statically used by the pipeline, bound to the pipeline bound, a descriptor set must have been bound to n at the same pipeline binding point. So basically this means that we're still not done. This chapter ends up in a state where we don't see our rectangle anymore, so we need to go on to the next one and see what else do we need to do. So, descriptor pools and set. The descriptor layout from the previous chapter describes the type of descriptors that can be bound. In this chapter, we're going to create a descriptor set for each buffer resource to bind it to the uniform buffer descriptor. Descriptor sets can be created directly. They must be allocated from a pool like command buffers. The equivalent for descriptor sets is unsurprisingly called a descriptor pool. We'll write a new function, create descriptor pool, to set it up. So right after we create our uniform buffers, we're gonna create the descriptor pool. So the way we create a descriptor pool is with this function. So let's see where we were creating the descriptor sets. Sorry, the uniform buffers, right? We want to set this up right after the uniform buffers. So if we scroll down, this has to do with the command pool index buffer. Here we're creating the uniform buffers. I'm gonna add a comment. Create uniform buffers, and right after that, and by the way, here we're still copying the vertex data, but I don't think we need that anymore. When we create the vertex buffer, we already copy the data, so this can go away. But what we need to add now is a call to this create descriptor pool, and it takes the device, some information to create the pool with this structure. We'll fill that later, but we need at least the structure type. And then we also need the allocation callbacks, and we get back our object. So here we can pass null pointer and also a mutable reference to descriptor pool. And we need to define this first. Descriptor pool, mutable null pointer, and this function can fail, so be sure to add a check for it. So now I'm gonna grab the actual function signature from the Vulkan header. I search for create descriptor pool. Here we can see the function signature, and we need to add it to our bindings. So here I have a definition of all the functions from Vulkan that we are using so far, and that we need to link from the Vulkan library. So let me add this somewhere down here. Create descriptor, cell layout. I'm gonna add it after creating the destroy descriptor cell layout. So we can add here create descriptor pool, text the device, the create info, the allocator, and gives back the descriptor pool. And also returns the decay result. Next, we can add this creation descriptor pool create info. So if we go to descriptor set layout create info, we can add it down here. And we can also search for it here. Text as type. Be next. Some flags. The maximum number of sets that we can allocate from the pool. And also the maximum, the pool size count. So I'm guessing how many sets we can allocate from the pool. And also takes an array of pool sizes. So now we can add the flags to our list of type defs for flags. And also with this descriptor pool size, we don't have it defined, and it's up here, just the descriptor type and the descriptor count. What do I use when I have? Because type is a keyword in Rust, so yeah, I'm gonna use the type. So now we are ready to go back to main and fill in this structure. Remember that it takes be next, which can be null, flags, max sets, pool size count. I'm guessing we will have at least one pool, right? That's correct, one pool. And then we proceed to define this descriptor pool size, where the type is gonna be uniform buffer. And the descriptor count is gonna be the maximum number of frames in flight. Max frames in flight as U32. Let's double check that this compiles. Cannot find BK descriptor pool size in the scope. Really? I just added it in here. BK descriptor pool size. What am I missing here? BK descriptor pool size. Did I save? I think I didn't save. So now it compiles. The descriptor pool needs to be recreated every time we recreate the swap chain. But we'll do that later. So maybe recreate main, recreate swap chain. Yeah, last time I commented out a bunch of things here. I'm gonna add comment here to do recreate descriptor sets and descriptor pool. Basically, until we do that, we won't be able to resize our window and have it work properly. And I'm guessing we need to clean up the descriptor pool. They are not showing it here, but here, yeah. Right before destroying the descriptor cell layout. So BK create descriptor pool. It's in here. We create it after the uniform buffers, so we'll also have to destroy it before destroying the uniform buffers. Okay, destroy buffer. So here, okay, destroy descriptor pool. We don't have that defined yet, but I will add it later. Descriptor pool probably has the same signature. And I'm gonna move this. Right, we need to add in the definition for this. Okay, descriptor, destroy, descriptor pool. And I think I guessed correctly. This function takes the device, destroy, descriptor pool, takes in the device, the descriptor pool, and the allocator. So now it should be compiling again. If I run it, I should still be getting the same error as before, but we should not get any validation about the descriptor pool not being destroyed. So let's continue with the tutorial. We were back here where we created the descriptor pool. After we have a pool ready, we can allocate descriptor sets from the pool. And they are creating these descriptor sets, create descriptor sets function. But we'll do it in line for now. So we need this bk allocate descriptor sets. So basically, bk create descriptor pool. After we have the pool, we can invoke the allocate descriptor sets. And what does it take? The device and an allocation information. Device. And the third parameter is just the pointer to where we want to write the descriptor sets. So descriptor sets as new pointer. Let me grab function definition for this one as well. bk allocate descriptor sets. Here it is. So back to our bindings. After destroy descriptor pool, we can allocate descriptor sets. This one can fail. Here I missed an S. And I'm going to go ahead and add the free as well, which is down here. Just in case we need to free the allocated descriptor sets later on. So pub function bk free descriptor sets text and device. The pool to where we want to return the descriptor sets, the count, and the actual descriptor sets. Now we need to define this structure. So copy that definition. Maybe we can add it right after BK descriptor pool create info. So down here. And let's search for it. Takes in the structure type. Next, the pool. The number or the count of descriptor sets we want. And returns the descriptor set layout. No? Or, no, the layout we want to use for the descriptor sets that we are allocating. Okay, descriptor set layout. And do we have this descriptor set layout? I don't remember. It looks like we do. So we can now proceed to fill this in. This type is gonna be BK structure type descriptor set allocate info. The next nothing. The descriptor pool. The descriptor set count. I'm guessing it's gonna be max frames in flight. Yes, that's the same number that we're passing in here, basically. And here we need to pass in the set layouts. And let me see how are they filling in this. So first we create we already have a descriptor set layout somewhere down there. So first we copy the descriptor set layout that we created for every frame that we can have in flight, and then that's what we pass in. So, and we also need the vector of descriptor sets. Yes. Let mute descriptor sets is a vector of null pointers. These are handles, Vulkan handles. And we need to resize it. Size it with the max frames in flight. Max frames in flight. So this is what we get back from here. And for the set layouts, you just copy. You can have let layouts is also a vector of descriptor set layout for each max frames in flight. And now I need to check that we indeed have defined this before. Where do we have descriptor set layout? Yeah, we have it. We created before creating the graphics pipeline, so it's okay. And are we able to copy this? Yeah, this is also a handle, so should be able to copy that. And here the problem is that we need a U32. And other than that, we also need to check that this function doesn't fail. And anything else? Any other compiler error? Check. Yeah, I have an error here. We need to pass in the layouts as a pointer. Layouts as pointer. And if I'm not wrong, this should compile now. And it does. Can we define this in line? Let me give it a shot. So basically, can I put this in here? Looks like we can, so yeah, I'm gonna inline this in here so it's cleaner. What next? What next? You don't need to explicitly clean up descriptor sets because they will be automatically freed when the descriptor pool is destroyed. That's okay. Hello, Red Chucks there. How are you doing? Good morning. So let me see. So now we have allocated descriptor sets. Pretty good. Me too, man. It's very early in the morning, but I wanted to finish with the descriptor pools and uniform buffers of the Vulkan tutorial. Okay, descriptors that refer to buffers like our uniform buffer descriptor are configured with a BK descriptor buffer info. This structure specifies the buffer and region within it that contains the data for the descriptor. Where are you from? From the United States? Maybe? So let me see, where do we use this? Yeah, USA. Yeah. I'm from Spain, so yeah. Okay, here they are creating a write descriptor set. If we are overwriting the whole buffer, then it's also possible to use the BK whole size. So where do we use these update descriptor sets? Do we just do it right after creating the sets, or every time we want to update the uniform? You live in a former Spanish colony? Yeah. Which region from the United States do you live in, if you don't mind sharing? West Coast or East Coast? Uh, Texas. Nice. So West Coast, right? Or uh, update descriptor sets. I want to see where do we have to update the descriptors. And they don't say. Yeah. Sorry, my geography knowledge is not that good. Sorry for that. Um, Using the descriptor sets. So in order to use the descriptor sets, we need to add in this command to bind them right before we draw. So command draw index. Right up here, we can also bind the descriptor sets. And I'm guessing this takes the command buffer. We want to bind the descriptor sets to the graphics pipeline. Are you working on a project, or are you just chilling, Red? Pipelines layout. Then 0, 1, descriptor sets at I. Which for us it would be the current frame. You recently finished working on a game jam game. Very nice. I've never participated on a game jam, so I feel like I don't have the skills yet to participate. I mean, I would like to, but I feel like I'm not capable yet. So if you want to share the game, please share a link. I would like to see it. Ah, you are fishing for people. Yeah, sure. Send me a link and I will check it out. Did you work on it alone, or did you work on it with a team? So descriptor sets 0 and null pointer. 0 and null pointer. You and one other person. Let me check it out. Let's see if I can. Controls. Just be aware that my browser is a bit slow while I'm streaming, but controls, spacebar to use an item, enter to level up, period to pass your turn, Interactions with items or the environment are different depending on whether you are in rage. And some credits. So it works on the browser directly, and there are also download links for native executables. Let me see. Spacebar to use an looks like a rock, like, no? Wait. So period to pass your turn. It reminds me to the Rust roguelike tutorial. I can grab some. Oof. I think I'm not doing so good. And period is to pass the. Looks cool, man. Yeah. Are you using WebAssembly, or what language did you use to develop it? Let me check the GitHub link. You're using Godot, the game engine, right? I haven't checked out Godot, but I've seen some streamers using it, but I'm not really familiar with it. So here are some scenes. Where are the scripts? Let's see. Yeah, it was made in Godot, which has its own like scripting language, right? I see. Looks pretty nice. Okay, I will save it for playing with it a little bit later on. Let me add it to bookmarks. I need to read through all of this carefully because I'm not very concentrated now. The maps are generated using the catalog of square decompositions at squaring.net. The organization is a giant mess. Don't worry about it, man. It will take some work for anyone else to understand. Do you know this? Well, I don't know if you are familiar with Rust, but there's this Rust, what was it called? Rust-like tutorial. I was, where is it? Sorry, roguelike. I was watching this other streamer the other day, and he was following through this tutorial, and has a lot of chapters. So maybe someday I will try out this. But looks like a lot of work and a lot of reading. Yeah, you support the author? Oh, that's cool. Yeah, I'm considering doing the same, but maybe I will try to implement some of these first. But yeah, it looks like he did great work with this. And what I like about it is that it's written in Rust, which I also like and I want to practice. So yeah, that's very cool. So was this the first game jam that you participated, or did you already participate on other game jams? I'm gonna try to continue with this. I need to add in these descriptor sets to our bindings. So k command. Bind descriptor sets. Fixing the command buffer. This is your 4th time that you participate on a game jam. Do you have any advice for participating into one? Layout. First set. Descriptor set count. Descriptor sets. This is the first time you used an engine for it, and the result is much better. So I'm guessing your recommendation would be to use an engine. If I'm reading, I'm reading you right. Okay, descriptor set. Dynamic offset count. And dynamic offsets. So now we have this command available to us, but we are still missing some other work to do. The previous times you tried to do things from scratch in pure script and always got back down in low-level stuff without much time to work on the game itself. Yeah, I can see that happening. Yeah, definitely. Or if you don't use an engine, at least use a language ecosystem anyone else writes games in. Like C++, or, well, Unity is a game engine also, but yeah, I agree that for a game jam, doing everything from scratch is not the best idea, because for a game jam, you want to do things like quick. So you need to have as much work done already for you, and you need to focus on the assets and gameplay, right? That's at least what I think without any kind of experience. But so mismatched types, expected raw pointer, const mute, online 615. I think I did something wrong here. But I cannot see it. This needs to be a reference. Now it seems to be working. Another thing that went well in this one is a willingness to paper over obscure bugs without really understanding or fixing them. What does it mean to paper over? Sorry, I'm not a native English speaker. I don't know this expression. What do you mean? Like you didn't fix all the bugs right when you find them. So you focus on the development of the game instead of spending too much time. There was a bug where some of the rooms didn't get activated. And the bug was never fixed. Okay. So yeah, I would say for a game jam, if it's not a critical bug, and it's something that the user won't notice too often, or won't prevent them from playing the game, then you can focus on something else. Instead, you throw some extra code that activates rooms in other situations as backup. I see. Yeah, I think it makes sense. You can try to fix the bug, but if you spend some time and you can figure it out, maybe you can leave it for after the game jam is finished, right? Okay, so where do we call this update descriptor sets? I'm gonna attempt to call it right after we allocate the descriptor sets. Here we are allocating the descriptor sets. What if I try to update them right after that? We need the device, and we want to update one descriptor set with this write descriptor set information structure. What's the name of the game jam? I didn't see it on the. Seven DRL challenge. Ah, I see now. I didn't know about this game jam. And now there's a voting. Okay, maybe I will take a look at this. And here are the rules. You had 7 days maximum to work on the game. I guess that's from the name. And they even provide some resources. And yeah, so all the games, the main theme is that the game needs to be some kind of roguelike, right? I see. So that's cool. And there are a lot of entries, like 205, yeah. That's cool. I would like to participate someday at one. Okay, I will try to not get too much distracted. So this descriptor set, we need descriptor write. We need the S type. The destination set. here we are using an index, so we need to do it for all of the descriptor sets, but I think I will need to check out the source code for this chapter. It's not clear to me. First, let's add the binding for this method. Right down here. Text the device. The count of descriptor writes. Then the descriptor writes array. And we can also have some copy descriptor sets. Hey, thank you for the follow, Red. I really appreciate it. For some reason, I don't see the notifications sometimes. I'm using string elements to show alerts, but it is not working so good. I need to look into that as well. Const vk copy descriptor set. And I think we'll need to add these two structures. So maybe after vk descriptor set allocate info. We can put it down here. I'm gonna copy all of this. And I need to modify these ones. And then just remove these ones. So what are we missing here? Descriptor image info and descriptor buffer info. Okay. Let's see. Descriptor image info. Takes in the buffer, an offset, and a range. And the descriptor image info. Takes a sampler, an image view, and an image layer. So now we have these two. And if I'm not wrong, we also needed the VK copy descriptor set. Yeah. Copy descriptor set. Source set. Source binding. Source array element. Destination set. Binding. Array element. And descriptor count. I hope I don't have to fill all of this. So for the right one, we have the S-type, next, test set, test binding, test array element, descriptor count, which we have one of. The descriptor type is a uniform buffer. And image info, I guess it can be null. And buffer info. Buffer info, probably we need it. Yeah. Should be one of those. But the texel buffer view, we don't need that. So that's all for the write descriptor set structure. Now we need the descriptor buffer info. I just want to see where do we call this update descriptor sets. So we do it in the create descriptor sets, so right after allocation, and we do it for every frame. So we were almost right, we just needed here the for I in 0 to max frames in flight. That's what I was missing. Where else? What else do I have wrong here? This net needs to be as big device size. And are we compiling now? Yeah. Let's give it a shot. Let's run this. Don't expect it to work. Validation errors on BK descriptor pool. Max sets is not greater than 0. So where we create the pool, here looks like I was doing it wrong. So create descriptor, where is it? Create descriptor pool. Pool size count is 1, and the max sets is the number of frames that we can have. So this should be max frames in flight. Probably casted. Yeah, it needs to be U32. If I run this now again. Render past beginning flow. Frame buffer must be a valid BK frame handle. And we are in the recreate swap chain. Yeah. I want to see why are we recreating the swap chain. Online 687. So it's either because we got back VK suboptimal or error out of date, or the frame buffer was resized. Probably the frame buffer was resized, because when we create the window, we get an event that says that, yeah. When we first create the pipeline, create graphics pipeline. Just want to disable this frame buffer resize thing. Okay, at least now we are not crashing. So we are not properly handling resize, but one step at a time. Let's get rid of these debugs. If I try to resize this, yeah, we get into problems when we recreate the swap chain. But if I don't resize the window, we are fine. So now the problem is that we don't see the rectangle again. And this is because when we update the uniform, okay, map. Here, notice that we are using all of zeros, an array full of zeros for all the matrices. So this will always be 0. What we need to do is maybe use the identity matrix, and we'll need to create this, of course. But we don't have this method yet. So far we were using this simple type def for a matrix. I'm gonna upgrade this to a real structure. mat4. Still keep the same data representation, but now we can add implementations for this structure. So we're going to create an associated function which returns self. Like so. Let me see if we are back to seeing something. Yes. Yes. So now, because we are using the right uniform, we see the rectangle. So let me commit this at this stage, and we have a few things to clean up, of course. Start using use uniform buffer. Create descriptor full sets and layout. And use uniform buffers. Push this. Right. So we have several things to fix. First, the recreation of the swap chain is not working anymore. So maybe we can start with that. Create swap chain. I uncomment this out. The problem we were having here is that this now takes the descriptor set layout, I think it was descriptor set layout, and we don't have access to this here. So I'm considering adding it to the swap chain context and recreating it every time. But we don't need to recreate it every time. Or do we? I'm not so sure. So if I add it here, or set layout, and I go to swap chain context and I add it here, set layout. Of course, I will need to well, here I already added. Now we can access it from the swap chain context. Then we can also uncomment this. But we need to recreate the descriptor sets and the descriptor pool. Right? If I run this and I try to resize the window, pipeline layout must be a valid pipeline layout. The validation error, we get it. Where exactly? When we bind the descriptor sets. So yeah, looks like the script descriptor pool. I'm gonna abstract this away, add a function for create descriptor pool, and we need the device and probably also the descriptor count. Here they don't pass any parameter, but create swap chain, create image views, create render pass, create graphics pipeline, create frame buffers, and create descriptor pool. Just a wrapper for now we can add here create descriptor pool. And probably we will need swap chain context descriptor pool to be in the swap chain. In here, we could use the swap chain context. Would that fix it? And then on line 636, we have a similar problem. Here we could reallocate swap chain context. Descriptor set layout and write into this would get rid of this to do. When we create the pipeline layout, we need the descriptor set layout. Let's try to run this like this. We seem to not have a valid pipeline layout. Where exactly? After we recreate the swap chain, bind descriptor sets layout. Bind descriptor sets layout. Pipeline layout. This one needs to be also from the swap chain context. I think that's the only problem we have here. Ooh. We get a ton of validations, but at least we are not crashing. Descriptor set blah 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 has not been destroyed. So we are still missing this code here. Do they recreate the uniform buffers? Recreate swap chain. I think we are doing unnecessary work. Recreate. No, we are not recreating the vertex buffer. What if I add this code? Down at the bottom. So after we recreate the descriptor sets, we immediately update them. We don't have access to the uniform buffers. Can we pass it in, maybe? This is so ugly, but if it works, it works. And it works. Yeah, look at that. We can finally resize our window. Oh, can we? Yeah, and we are recreating the swap chain and using uniforms, so we should be able to animate the uniform now, the model matrix, and make this rectangle rotating. So let me, we get still some validations when we we need to clean up the previous pool and sets before we recreate them. So first let me get rid of the debug. Next on recreate swap chain. Before we create a new descriptor pool, we need to decay, destroy descriptor pool. Device. So we resize. We get less errors, at least. What's the error? Descriptor pool must be a valid descriptor pool handle on. Yeah, I think I know. Destroy descriptor pool. We call it when we recreate the chain, but we also call it at the end of the program. So here we should take it from the swap chain context. And descriptor set, get complaints. Let's see if that fixes it. Yes. Fuck yeah. So we managed to recreate the swap chain. Still need to do a whole bunch of cleanup, but at least we have the functionality that we want. Fix recreation of swap chain. To account for to recreate I'm recreating Descriptor. Okay, so I think what we will do next is try to animate the uniforms. This. Do animate with time to have other to-dos, yeah. So next time we'll have to fix this, we'll have to implement some matrix operations to create rotation matrices. So I will try to research that offline before we deal with it. Oops. But yeah, the result for today is this. Pretty much the same as last time, but now we are using uniforms. So thank you all for watching, and I will see you next time.